dear students, welcome to Bosco Campus Vision. This is Seema Dudley. Welcome to my another video on data analytics. In this video, we will discuss about the topic data integrity. The term data integrity means the data is not altered in between its storing time, processing time, and retrieval time. ഒരു ഡേറ്റ നമ്മൾ സ്റ്റോർ ചെയ്യാനായിട്ട് കൊടുക്കുന്ന ടൈമിലും സ്റ്റോർ ചെയ്യുന്ന ടൈമിലും അത് പ്രോസസ്സ് ചെയ്യുന്ന ടൈമിലും അല്ലാന്നുണ്ടെങ്കിൽ അത് റിട്രീവ് ചെയ്തെടുക്കുന്ന ടൈമിലും ഇൻ ബിറ്റ്വീൻ അത് ആ ഡേറ്റയ്ക്ക് ഓൾട്രേഷൻസ് ഒന്നും വരുത്തുന്നില്ല എന്ന് ഉറപ്പ് വരുത്തുന്നതാണ് ഡേറ്റ ഇന്റഗ്രിറ്റി. So data integrity talks about the correctness of the data. It is very important for us to have a guarantee or assurance that the data stored in HDFS is correct. However, there is always a slight chance that the data will get corrupted during input-output operations in the disk. HDFS creates the checksum for all the data returned to it and verifies the data with the checksum during read operation by default. Also, each data node runs a block scanner periodically, which verifies the correctness of data blocks stored in the HDFS. Hadoop creates distinct checksum for every 512 bytes of data. And we know that in Hadoop, different same data will be stored in different places. So to provide data integrity, all data that enters into the system is verified by the data nodes before being forwarded for storage or further processing. Data sent to the data node pipeline is verified through checksums. And if there is any correction, then an IO exception will be received. And this IO exception should be handled in an application specific manner. And the client read from the data node also goes through the same process. In addition to block verification on client reads, each data node runs a data block scanner to provide data integrity. We know that Hadoop maintains copies of data. That means it will be storing the same data in different places. So if a client detects an error when reading a block, it reports the bad block and the data node it was trying to read from to the name node before throwing a checksum exception. The name node marks the block replica as corrupt so that it does not direct any more clients to it or try to copy this replica to another data node. It then schedules a copy of block to be replicated on another data node. So its replication factor is back at the expected level. Once this happens, the corrupt replica is deleted. And for every file created in Hadoop local file system, a hidden file with the same name in the same directory with the extension .filename.crc is created. This file maintains the checksum for each 512 bytes of data in the file. The maintenance of metadata helps in detecting read error before throwing checksum exception by the local file system. The next feature is compression. We are aware about the volume of data Hadoop deals with. File compression brings two major benefits. It reduces the space needed to store files and it speeds up data transfer across a network or to or from the disk. When dealing with large volumes of data, these two features are very important. There are many tools, techniques, and algorithms commonly used by Hadoop to support compression. And popular compression tools are gzip, bzip2, lizo, then snappy, and zip. These are the commonly used compression tools in Hadoop. The next term is serialization. We know we are using structured as well as unstructured data in Hadoop, and we have to transfer the data between the networks. And we transfer the data in the row state. The raw form of data is a sequence or stream of bits. This raw form of data is the one that travels over the network and is stored in RAM. And also we store the data in RAM or in any other persistent media. Serialization means it's a process of converting structured data into its raw form. Deserialization is the reverse process of serialization. And in Hadoop, this serialization is mainly used for inter-process communication and also for persistent storage. More about inter-process communication. In Hadoop, inter-process communication between nodes in the system is implemented by using remote procedure calls. That is, RPC technique is used for inter-process communication. The RPC protocol uses serialization to convert the message into a binary stream, and it is then transferred to remote nodes. And at the remote nodes, these data will be deserialized into its original message. And more about the RPC serialization. The RPC serialization format is expected to be compact. That is, it should be efficient in using the network bandwidths. Second is fast. That is, very little performance overhead is expected for serialization and deserialization process. And third one is extensible. That is, to adapt new changes and requirements. Then next is interoperable. Interoperable means to exchange and also to able to use it. Okay, information exchange ചെയ്യാനും സാധിക്കണം, ആ information use ചെയ്യാനും സാധിക്കണം. അതിനെയാണ് interoperable എന്ന് പറയാം. And the format needs to be designed to support clients that are written in different languages to the server. Okay, so the assignment question: explain the terms data integrity, compression, and serialization. So complete the assignment and forward it to the email ID provided to you. Thank you.